11.2, day 2. You are dividing rational expressions. Essential question, what's the difference between multiplying and dividing expressions? The good news is if you can multiply, you can divide fractions because, for example, if I had given you a dividing fraction problem, this is as a reminder when you would do keep, switch, flip, or keep, change, flip. I'm not sure how you know it. So you keep that, change division to multiplying, and you just multiply by the reciprocal. So multiply across, I get 4 over 6, which reduces to 2/3. So we're obviously doing more challenging problems than that. But if you remember that multiplying is the same as dividing is the same as multiplying by reciprocal, and you know how to multiply, this shouldn't be too bad. So just as a reminder, what is a reciprocal? It's just the flip the fraction around. So for example, this one, the reciprocal would be 3x squared minus 5 over 5x minus 2. That one's easy. Ones that people get confused are on like this because they don't see it as a fraction. Remember that this is over 1. So when you flip it, 1 goes on top and the 2x minus 7 goes on the bottom. So here's what your problems will look like today. So your first step is you're going to keep, switch, flip. So I'm going to keep the first fraction, change to the division, changes to multiplying, and then you're going to flip the second one. So it's going to look like this. Then this becomes exactly what we were doing yesterday. So I'm only going to focus right here and think, okay, how do I factor that? Well, b is missing. It's a difference of squares. So I'm going to square root them, and I get x minus 5, x plus 5. Then I'm going to go to this part right here. What can I do there? I can take out a 4, and I'm left with x plus 7. Multiplying. Then I'm over here. I'm going to look at this part right here and think, how do I factor that? There's 3 terms. It is a shortcut. So I'm going to think my factors of 14 that add to 9, and it'll be 7 and 2. So x plus 7, x plus 2. And on the bottom, x minus 5, I can't do anything with that. That's just x minus 5. You might want to put in parentheses, though, to remind you that those are locked together. So remember, multiply, you just multiply straight across. So basically, this is going to become one giant fraction. And then you're going to cancel things out. Good news, you don't have to worry about excluded values in this section. It just gets a little crazy, so we don't make you do it. So I can cancel out these x plus 7s. I can cancel out this x minus 5 and this x minus 5. And I think that's it. So my final answer would be x plus 5, x plus 2 over 4. That's it. So what is the new step today? The new step is just that you have to keep, change, flip, or keep, switch, flip. You have to change division to multiplying and then do the reciprocal of that second fraction. Step 2 and 3 is the same as what we're doing yesterday because then really that division problem turns into a multiplying. Excluded values are not a focus, so you don't have to find them for this section. You can pause the screen so you can write that down on your notes. So remember, what is the quotient? Same thing as saying divide. So I'm going to keep, switch, flip to start off. Staying organized in this section is really important. Okay, and then I'm going to go through and factor. So I'm going to think, okay, what can I do with 4k plus 8? I can take out a 4, and I'm left with k plus 2. On the bottom, 6k minus 10, I can take out a 2, and I'm left with 3k minus 5. And then I'm going to go over here, 9k minus 15, I can take out a 3, and I'm left with 3k minus 5. And then on the bottom here, I have 3 terms. It is a shortcut one. What multiplies to 8 and adds to 6? 4 and 2. So k plus 4, k plus 2. And now it's a multiplying problem, so they're all just going to go next to each other basically. And now I can cancel things out. I can cancel out the k plus 2. I can cancel out the 3k minus 5. And then on the top here, you're left with 4 and 3. Now, some people go, oh, you can reduce these. You can do it there. That's fine. Or you can multiply straight across and reduce it at the end. Your choice. I'm going to multiply across. I have 4 and I have 3, so I get 12. And then I have 2 on the bottom. 12 over 2 gives you 6. So that whole giant problem really just comes out to be 6. Oh, I forgot something. Just kidding. What did I forget? I forgot the k plus 4. So the 6 would be on the top, but the k plus 4 is still on the bottom. I forgot about that. I didn't see it. So that would be your final answer. All right, then moving on to one that looks like this. I wanted to do one like this because, again, it's that weird situation. This is over 1, so it's still keep, switch, flip. And then you're going to switch this and flip that around. So I'm going to go ahead and factor the top. Again, it's a shortcut, but I've got the negatives. I think 11 and 1. How do I make that add to 10? 1 would have to be negative. So it's x plus 11, x minus 1. On the bottom, 11 and 1, it's all positives. That adds to 12. And then times 1 over, and I'm just going to group that. I can't do anything with x minus 1. Just put it in parentheses. Then I'm going to cancel. I can cancel out the x minus 1s. I can cancel out the x plus 11s. And my final answer is just 1 over x plus 1. Okay, this is the second part. It's really the same thing. It just looks weird, okay? It's going to be like lots of fractions, fractions, and fractions, okay? So they're going to look like this. What you need to know is that the big line really means divide. So it's just a weird way of writing it. I'm going to reset this up. So what this really means is that top fraction divided by the second fraction. Okay, now I can keep, change, flip. So now it just becomes like the other one. So keep, change, flip. Then I'm going to go through. I can't do anything with 1. I can't do anything with q plus 4. I'm just going to group them together. I can take out a 2 here. And I'm left with q plus 4. And then on the bottom, 2q to the second is just 2q to the second. The q plus 4s will cancel. Maybe you see this right now, maybe you don't, but this 2 over 2 right here, those aren't connected with adding or subtracting, so you can cancel those out. And then you're just left with 1 over q to the second. Again, the new part, though, is just that the big line just means divide. That one's not too bad, but one that looks like this, people get confused. So remember, this is the division. So if I were to rewrite this problem, it would really look like this. And then I'm going to keep switch flips. So I'm going to keep the first one. Might be nice to put it over 1 times t plus 2. Can't do anything there. T minus 3. Flip to that. So factor your top right here. This is negative 3 and 2. Gives me negative 6 and adds to negative 1. These I can't do anything with. But now I can cancel. I have a t minus 3 on the top here. Some people want to cancel out those t plus 2s. You can't. They are both on the top. In order to cancel out, they have to be on the top and on the bottom. So your final answer here is t plus 2 times t plus 2 over 1. You don't really need the 1, so it's actually just this. Some people might write that as t plus 2 parentheses and then squared. That's also correct. I am going to go over some other examples in another screencast, but you do have homework is on Schoology, and it is 11.2 day 2 dividing. Okay. Those of you who need some more examples, I know I went through fast. I'm going to have a separate screencast. You can watch the other screencast for those examples.